Hi, this is Dr. Graves from the CSUN Geography Department and geographyplanet.org. This is a video tutorial that helps students learn to do contingency analysis using the chi-square test. The requirements for the data include that it should be a random sample, and we have a sample here of students at Cal State Northridge based on two categories at least. And in this example, we're going to use major and the institution where the students come from. These are transfers, and what it is, it's going to be sort of a count, which is in the sum column of the students per college. And what we're going to ask of the software is, do the colleges that send students to CSUN, are they sending them proportionately? So we'll have an actual number of majors and by institution that sent them, and then we will have an expected number based on the overall trends that assume that all of the feeder colleges are proportionately sending students to CSUN's campus. The requirements of the contingency analysis is that no more than 1/5 of the expected frequency should have any less than 5 observations, and that none of the expected frequencies should be less than 2. So the first thing that we're going to do is that we're going to put this data into a pivot table in order to extract specifically what we're looking for. So click somewhere in your data table, click on Insert, and click on Pivot Table. Click OK. And we're going to pull down we're going to put majors in this column. So here are all the majors. And the institutions are going to go into the column ID. No, not the institution ID, the institution itself. So Antelope Valley, College of the Canyons, Glendale, Mission, Moore Park, etc. And but we are going to, for the sake of simplicity, I'm going to pull up college here, and I'm going to filter it because I'm only going to, in this example, evaluate majors from social and behavioral sciences, which is the college that geography is in. So I'm going to click OK on that filter, and then I'm going to bring that over here. So now it's just anthropology, geography, history, etc. And then our sum is going to be here in the sum of values, and that gives us the number of majors from each of the cooperating universities. And this is going to be our observed, and we may have to exclude Pan-African studies because the numbers are so small. So why don't we do that right now? Right click, filter. We will find Pan-African studies on the list and click that. That should remove it, and now we don't have very many extremely small numbers that will cause problems. There's just a couple of anthro and geography majors from Mission, but the expected number should be far larger because there are larger numbers here on the grand total. So that's part one. For your homework, you're going to do this a little bit differently. You're going to not filter anything, and you're going to look at the institutions and colleges instead. So in the homework, you will have institutions here, but rather than major, you will have college, and they will not be filtered. All right, so this is our pivot table. What I want you to do is to copy it and come to a new sheet and paste the values. And then if you want to, you can then paste the source formatting. So it's kind of pretty that way. As usual, we're going to move our sums away from the data. And I want you to make a note of the number of rows and the number of columns of data. So these, I'll put them in green. These are observed. So we have a count of 8. So 8 rows. And how many majors do we have? That is 9. So we have rows are 8, columns are 9. Our degrees of freedom for this test are therefore going to be 7 and 8, and we multiply those together, 7 times 8, and that's our degrees of freedom that we're going to use later on. So here's our observed. How do we get the expected? Well, we're going to build, first is percent majors. And in order to calculate the percent majors, type an equal sign, indicate the number of total majors in the grand total column, and divide that by the grand total of all students, that is in the lower right-hand side of the matrix. Make sure you press F4 to freeze the reference and press enter. You may copy this down all the way and you will see that it's about 3% of all students are anthropology majors, and oh wow, 44% are psychology majors. How interesting is that? In order to double check your calculations, copy one more time down and you should get a 1 there. And now we can repeat this just to find out what is the percentage of all students that are from each of the community colleges, and paste across. And then we see that something like 24% of all students are from Pierce. We might want to do that in order to calculate this chi-square in 2 different ways, but we're going to go across and we're going to take a look and we're going to evaluate the majors instead. So copy this matrix of values here over, and let's give it a new color. And these orange cells are going to be our expected values. So how do we get the expected value? Well, we're going to multiply the percentage of all majors, and we have to freeze the cell reference so that the column doesn't move, and the column reference is L in this case. We want to multiply that by the total number of majors from that school. So if 3% of 366 students from Antelope Valley College are anthropology majors, as they are across campus, then we should have 11 majors from Antelope Valley College, not just 3. So Antelope Valley College is not sending as many anthro majors as you would expect. So once you have, I made a mistake there, I need to freeze the 11. So in order to do that, you can either just put a $sign in like that or press the F4 key a couple of times. By doing this, that allows us to copy this formula over and across, and the numbers will all the way they ought to. So there's the values, the expected values. I'm going to reduce the number of significant digits, and what we need to look for in here is just to make sure that there aren't any zeros or very many values that are less than 5, and as it turns out, there aren't any. So we have not violated the conditions of the chi-square test. So now all we need to do is to engage the chi-square formula. And there it is. For the contingency, there are two sums. So we're not just summing up the rows or the columns. We're going to sum up the rows and the columns, but we'll do sort of both in the context of this video. So observe minus expected squared divided by expected. And we're going to do all of this in a matrix that's right here. So I'm going to copy this one more time down to here. And we can get rid of those values. So it is observed, which is in green, minus expected, and we're going to square that, divided by, once again, by expected. So this is our first step here, the observed minus expected divided by expected. And here are our values. Okay, and so this in its own right is interesting, and it's worth taking a second to just sort of stop. What we're going to do is highlight all of this data and go to Conditional Formatting and put a green to white color scheme on that. And that's kind of hard to see, so let's kill off the orange. And we see these areas that are darkest are the areas that are most different than expected. And here we have Moore Park with an expected number of anthro majors at 28, but holy moly, they're sending 73. So that's really a large discrepancy, and so that's a huge contribution to the chi-square. And so we can, what we're going to do over here is sum up the rows, which is telling us which of these rows of data, which of these majors are most different than expected. So it looks like urban studies is most dead on and sociology is most unusual. And it looks like Mission and Ventura College are both sending, are both far from expected. And then we can do the same for the sum here at the bottom, and we can see which colleges are sort of bucking the trend most. So it is, it appears to be Moore Park, and that's largely because of anthropology, but also Mission. And the school that seems to be most in line with the overall trends is Antelope Valley College. In order to calculate chi-square, all we have to do is sum the entire thing. Now, this is for the double matrix, the contingency, and we have this massive value of 506. And if you've done any of these preliminary calculations, you know that's a huge number. Nevertheless, we will, this is chi-square, and then our p-value, we can do this because we want to do it right and complete it. So that is chi-square distribution right, and this is going to give us the sort of one-tailed probability that that number, the chi-square, is indicative that the observed and expected are the same. The degrees of freedom is over here, which we calculated at the beginning. We're going to get a number that's in scientific notation, so that's 8 times 10 to the negative 74. And if you find that bothersome, change it to a number, and you'll find that it's 0, 0. And you could click on this expansion a number of times, and because that number is so large, this number is going to be extremely small. So we are very, very confident that these numbers don't match up. And it's not surprising because it's hard to get a large matrix of double contingency tables to match up closely. That is the end of this video tutorial.